Hello everyone, we are Group mawar and today we will introduce the trees. Okay, now I will give you the introduction of trees. First of all, trees stands for the theory of innovative problem solving. The word trees comes from the Russia term. In simple words, trees is a systematic method used to solve problems and create innovative solutions. Unlike normal brainstorming, trees does not only depend on personal creativity, intuition, or trial and error. Brainstorming usually asks people to think of many ideas, but not all ideas are practical. Trees is different because it gives clear principle, toys, and patterns to help users solve problems in a more logical and effective way. The main idea of trees is that innovations does not happen randomly. Instead, innovation often follows certain patterns. A problem in one industry may be similar to a problem in another industry. Therefore, people can study successful solutions from other fields and apply them to their own problems. Another important concept in trees is contradiction. A contradiction happens when improving one part of a product or system creates another problem. For example, we may want to make a product stronger but also lighter at the same time. Trees helps users solve this contradiction instead of simply accepting a compromise. Okay, next, let us look at the origins of trees. Trees was developed in the late 1940s by Jerens Alshaler, a Swedish engineer and the patent office. While working in a patent office, he studied many patents and found that successful inventions often shared repeated problem-solving patterns. Based on this research, Alshaler and his colleagues developed important trees toys, such as the 40 inventive principle and the contradiction matrix and the laws of technical system evaluation. At first, trees was mainly used in engineering and technical problem solving. Later, it spread to other fields such as business, education, product design, and management. The significance of trees is that it makes creativity more systematic and practical. Many people think creativity only comes from nature talent, but trees shows that creativity can also be learned through methods and toys. It helps individuals and organizations find better, more efficient, effective, and user friendly solutions. In conclusion, Trees is an important toy for innovative problem solving. It helps users understand problems, identify contradiction, and apply proven solution patterns. Trees shows that innovation is not just about random idea, but also about systematic thinking.
Hello everyone, today I'm going to talk about Theory of Inventive Problem Solving or TRIZ. TRIZ is a way to help us solve problems better in a more structured and logical way. First, let's look at inventive problem solving. TRIZ tells us that invention is not random. It actually follows partners, so we don't have to just graze ideas. Instead, we can learn from past solutions. One important idea is ideal final results or IFR. This means the best solution has no extra cost, no harm, and works profitably. In other words, it is the simplest and most implementable solution. For example, before we used the cables to charge phones, but cables are not covenant and can break. So the ideal situation is no cable. This why have a wellness charging today. Also, TRIZ helps us think in a new way. Sometimes we are stuck in old thinking. This called philological interiorize helps us break that and look at problems differently. Next, I will talk about how systems evolve. TRIZ says technology does not change randomly. It develops step by step, following partners. The first idea is increasing ideality. This means better performance, but lower cost and fewer problems. So, over time, systems become more efficient. For example, mobile phones before they were big, expensive, and simple. Now, smartphones are smaller, cheaper, and can do many things. Other idea is unequal development. Some parts improve faster than others, and this can cause some problems. We can also call this a bottleneck. So, innovation is needed to fix it. Also, systems become more fixable over time. For example, old watches are fixed, but smartwatches are more advanced and systems become smaller. This shows the trend from big systems to multiple systems. For example, strategy becomes smaller and linear. Finally, I will talk about technical contradictions. A contradiction means when one thing gets better, other things get worse. This is a very common problem in engineering and design. For example, in airplanes, if we make it stronger, it becomes heavier. This is a problem because heavy planes use more fuel. Normally, people choose a composite, but TRIZ does not encourage compromise. Instead, TRIZ tries to remove the contradiction completely. For example, using special materials, planes can be strong and still launch. Other example is foldable phones. They need to be strong and flexible, and the sometimes so system needs two opposite properties. TRIZ solves this by using different continents, like different states at different time. TRIZ also gives tools like a 40 prospects and a matrix to help us solve problems step by step. So, instead of grazing, we follow a clear method. So, basically, in my part conclusion, TRIZ helps us think more clearly, solve problems more effectively, and create better solutions. And more importantly, it gives us a way to innovate with logic, not luck. I would like to interview the next group member.
For this slide, I will introduce the basic idea of TRIZ and its main tools. TRIZ stands for Theory of Inventive Problem Solving. It is both a theory and a practical method. It helps people solve problems in a more systemic way. Instead of using trial and error, TRIZ give us a clear structure to follow. This method is often used in engineering and design, especially when problems become complex. Many traditional methods rely on expense or guessing. However, trees focus on logic and patterns from past innovations. The main objective of trees is to identify contradictions in a system. A contradiction means when we try to improve one thing, another thing becomes worse. This happens very often in real situations. Trees also help us generate innovation solutions. These solutions are not random ideas, but ideas based on proven principles. At the same time, trees aims to improve system performance without increasing cost of complex too much. There are two important tools in trees. The first one is the 14 inventive principles. The second one is the contradiction matrix. These tools work together to guide problem solving. Overall, trees help us to turn problems into structured opportunities for innovations. Now I will explain the 14 inventive principles. These principles are developed from study many patient and successful inventions around the world, expect analyze common patient and summarize them into 40 general principles. These principles are mainly used to solve technical contradictions. Instead of thinking randomly, we can use this principle as a guide to generate ideas. This makes creative more structured and efficient. Let me give some simple examples. The first one is separation. This means we divide a system into parts. For example, furniture can be separated and combined easily. This makes it more flexible to use. The second one principle is taking out. This means we remove something that is harmful or unnecessary. A good example is noise cancelling headphones. These remove unwanted noise so user can focus better. The third one is the third one is universality. This means one product can perform multiple functions. Smartphones are a good example. They can be phone, camera, GPS, and many other tools into one device. Another principle is dynamics. This means the system can change or adjust. For example, office chairs can be adjusted to fix different user and improve comfort. The last one is copy. This means we use models or simulations instead of real system. Flight simulators are a good example because they allow training without real risk. All these principles help engineers and designers find practical and innovation solutions more easily. The goal of trees is to solve these contradictions without making trade-offs. In other words, we try to improve both sides at the same time. The contradiction matrix is a tool that helps us to do that. We can give a suggestion on which inventive principle we can use. There are three main steps to use the matrix. First, we identify the parameter we want to improve. Second, we identify the parameter that become worse. Third, we use the matrix to find suitable inventive principles that can solve the contradictions. Let's look at a simple example. If we want to make a smartphone lighter, the problem is that it may become less durable. Using the contradiction matrix, we may find solutions such as using new materials or applying the separation principle to redesign the structure. The tool has several benefits. It reduces the need of trial and error. It gives a clean direction to problem solving, and it helps managers solve problems more efficiently. Overall, the contradiction matrix makes the innovation process more structured and effective.
Now I will explain evolution mapping in TRIC. Evolution mapping is a tool that helps us understand how a system changes over time. It shows that systems do not change randomly. Most systems follow similar patterns of development. First, evolution mapping shows the direction of improvement. Over time, many products become smaller, faster, and more automatic. For example, machines today need less human effort. Some systems
can even work by themselves. This helps engineers think about what may happen in the future. Second, it helps us understand the stage of a system. A system can be in an early stage, growth stage, or mature stage. In the stage, the system is simple and not fully developed. In the growth age stage, the system improves quickly and new features are added. In the mature stage, the system is stable and change becomes slower. Knowing the stage is important because it helps us choose the right type of innovation. For example, in an early stage, we may need big changes. In a mature stage, we may focus on small improvements. A simple example is mobile phones. At first, they were only used for calling. Then, they became feature phones with more functions like messaging. Today, smartphones can do many things such as using apps, taking photos, and browsing the internet. This shows a clear evolution path. In TRIZ, evolution mapping helps people understand past develop, analyze the present system, and predict future innovation. Therefore, it is very useful for long-term planning and creative problem solving. Now, I will explain functional analysis. Functional analysis is used to understand how each component in a system works with other components. It focuses on the function between components, not only the structure. This means we care more about what each part does, not just what it looks like. First, we list all components in the system. Then, we study how each component connects and works with each others. These interactions are important because they affect how well the system works. In TRIZ, functions are divided into three types: useful, harmful, and unnecessary. In a useful function helps the system work better and improves performance. A harmful function causes problems and reduces efficiency. An unnecessary function that does not add value and may make the system more complex. The goal of functional analysis is to improve the systems. We try to remove harmful functions, reduce unnecessary parts, and improve useful interactions. By doing this, we can make the system more efficient, simpler, and easier to manage. For example, in a machine, one component may create friction. This friction can reduce efficiency and waste energy. So we can redesign this component or remove it to improve performance. Another simple example is a product with too many parts. Some parts may not be needed. Removing these parts can reduce cost and make the product easier to use. So, functional analysis helps engineers understand systems clearly and find better ways to improve them.
Hi everyone, let's look at how TRAC actually works. Most people treat innovation like a lottery, using trial and error and just hoping for a lucky break. TRAC moves us away from the guesswork and into a repeatable discipline. Instead of asking, what if we try this, we start asking, what exactly is colliding here? This brings us to step 1, decoding the issue. The problems you see on the surface, like a machine overheating, are just smoke. The real fire is a contradiction buried underneath. We call this dialogue. It happens when you try to improve one parameter but another one takes. Think of a rubber arm. If you make it thicker to handle more stress, it gets heavier and slower. TRAZ doesn't ask you to find a happy medium or compromise. It aims to break the connection entirely so you can solve the problem without trade-offs. Once you name these two conflicting variables, you are already done half the work. Now, how do we actually solve the conflict? Step 2 is the contradiction matrix. Think of it as a librarian, not a vending machine. It won't give you a finished blueprint, but it flags innovative principles from decades of patent data that have entangled similar nodes before. It's up to the engineer to translate those abstract ideas into specific design. Next, step 3. The reality filter. You have to filter those principles against your actual constraints, like budget, tools, and your team's skill level. The best fixes usually fuse two or three principles into one unique solution. Finally, step 4. Stress testing. This is where the idea meets metal. Your first prototype might disappoint you, but that's just the first round of vital feedback. You iterate through a test-adjusted test loop until the contradiction is dead and buried, not just covered by a compromise. To conclude, TRIC removes the randomness from innovation. It doesn't guarantee every idea works, but it ensures you don't waste time wandering in circles. It keeps the box you are thinking outside of in clear view.
I will talk about the tree and why it is important. The tree sentence of a series of the events, the problem solving it is was created by the Gary Actualer. The main idea of tree is to help people solve the problems in the smartest way. In many situations, when we try to improve the one things, another things become the worse. Well, for example, it is will make a product liar. It is made become the workers. This kind of the problems, it is called construction. The trees helped us solve these constructions without making a compromise. It is mean that we do not need to choose the one and give up the other. So in this we can find solutions that improve the both things at the same time. Well, because of this, the trees can improve the efficiencies and helps people create better idea. So it is widely used in many industries such as the engineers, business, and education. Well, the tree is used in many different fields. The first in the engineers and the product design, the trees help improve how products work. It is also helps solve problems when two things do not match well, like the making a product stronger but also lines. Engineers can use the trees to find a better designs without losing the quality. The second, in the business and the management, the trees help the companies service costs and work more efficiently. It is can also help the managers make the better decisions and improve work proposals. For example, the companies can use the trees to reduce the cost but still keep the good product quality. The third is in information technology. The trees help to solve the systems problems. For example, the systems many need to be the fast but also service. Well, the trees help the find ways to balance both the speed and the security so the systems can work better. Well, the finally is in education. The treat helps students think better and solve the problem. Teach use it to help the students come up with the new idea and learn how to deal with real life situation. It is also help the students become more creative and confident. However, the treat it is used become it can be applied in many areas and help the people find better and smart solution. Now let's look at the real case from the Samsung. The Samsungs want to make the smartphone the thinner and lighter, but at the same time still the stronger and durable. This created a problem between the weight and the stress because the lighter phones are usually not as stronger. So to solve the problem, the Samsung used the trees idea. They used the better and strongest material and they also changed the instant design of the phone to make it more efficient. Because of this, they were able to make the smartphones and are both light and stronger at the same time. This also improves user experience and product quality. Well, this case shows the trees can help solve the real problems in smart way. It is always the companies to improve the products without making difficult trade-off. So, in conclusion, the trees it is useful tools that helps the people find a better solution and create more innovation products.
The TRIZ approach provides a systematic way of solving problems. The TRIZ approach employs a number of stages from the point where the user identifies a problem up to the point where a solution to that problem has been arrived at. For example, the first step in the TRIZ approach entails the definition of the problem. This is followed by identification of the contradictions within the problem. Thereafter, the selection of appropriate techniques is done. The second, TRIZ enables people to think in innovative and creative terms. The theory of TRIZ relies on proven and well-known inventions. All those ideas have been converted into basic rules. Those rules allow users to come up with solutions in respect of their own challenges. There will be no need for people to rely on their experience and luck. Moreover, TRIZ help people find direction when they get stuck. In addition, it allows generating innovative ideas quickly. The application of TRIZ is challenging for novice users. Many theories and techniques must be mastered. These terms may appear strange and hard to comprehend. Poor training will lead to confusion. Wrong use of tools may result from poor learning and understanding of the theory. The learning process is time-consuming and exhausting. The second, TRIZ is most effective on problems that are technical or structured in nature. Such problems tend to have contradictions that can be clearly identified along with goals that are well defined. Not all problems are technical or structured in nature. There exists some unstructured problems that require a flexible and creative mind. Problems of management, marketing. In such situations, the use of TRIZ may become restrictive and difficult for users. TRIZ is a useful way to solve problems. It gives a clear and step-by-step method to create new ideas and uses creative thinking with logic. With TRIZ, people can solve problems quickly and well without making many mistakes. It also helps people stay organized. TRIZ is not only for one area. People can use it to improve a product or system, make a company stronger, and even solve daily life problems. It also helps deal with difficult situations when solutions seem impossible. But people should not expect it to understand all TRIZ methods at once. It needs time, effort, and experience to use it well. Sometimes people also need to think in a flexible way. In conclusion, TRIZ is an important tool for innovation. If used correctly, it can bring many benefits in both work and daily life.